Okay, what we're going to do now is go through the classwork. So what I suggest is that after the first lecture video, you try doing these on your own. Or what you may want to do is watch me do the first couple problems, and then maybe stop it and try to complete this on your own as practice, and then watch the video as I go through all of them. So whatever is going to help you best. But I do like to kind of participate in practicing the problems with you as much as we can in an online environment. All right, so the purpose of these 7 problems is to practice writing the null and alternative hypotheses, stating which one is the claim in the problem that we read, and then practice writing both type 1 and type 2 errors. In my experience teaching statistics over the last 12 years, this has been the part that the students have the hardest time with, just writing the null and alternative hypotheses. I think you will find with the next lecture video using JASP that getting the p-value is very easy. And then we have pretty easy logic with the p-value of interpreting it as less than alpha, then we reject our null. And if it is greater than alpha, then we fail to reject our null. So I don't think that you're going to find the software component of this section very hard, but it can take a little bit to click on how to write the null and alternative. All right, so let's practice. Number 1, a consumer group claims that the mean annual coffee consumption by a person in the U.S. is 23.2 gallons. A random sample of 90 people in the U.S. has a mean annual coffee consumption of 21.6 gallons. Assume the population standard deviation is 4.8 gallons at alpha equals 0.05. Can you reject the claim? So this is, a possible, this honestly, I'll be honest, this is more like a textbook problem because in the real world we have data. So in the real world, we don't get these sentences at all. These sentences go away, and what we get is a variable in a column of a spreadsheet. Okay, and that's what you're going to see with the next video. And so we're going to use our real data, our raw data, to test a claim. All right, and this sentence here, and I will underline it, this sentence is our claimed statement. So we have this consumer group making this claim. All right, and what is it that they are claiming? They claim that the mean annual coffee consumption is 23.2 gallons. And so what I like to tell people to do to practice these until you get the hang of it is to literally write that out. So we have mean, which is mu, is means equals in math, 23.2. All right, and now we ask ourselves, all right, so I've written this sentence in math form. Is this math sentence, is it going to be the null or alternative hypothesis? Okay, and the answer is if it includes any form of equality, so it's equal, greater than or equal, or less than and equal, then it has to be the null. All right, and so that is our null. That's the one we read in the sentence. That is our claim. Okay, now we just need to write the alternative. All right, and that is just the mathematical opposite of equals. And so I am going to need a, let's see here, I'm going to need an unequal symbol. All right, where am I? There we go. All right, unequal to 23.2. All right, and so we would use our data to test this claim. All right, so we want practice interpreting a type 1 error. All right, let's review what is a type 1 error. A type 1 error is H naught is true. Oops, capitalize that H. H naught is true, but we reject the null. So the null is true, but we reject the null. All right, so how would we put that in terms of this particular problem? All right, so what it means is this is true. So the mean annual coffee consumption is 23.2 gallons, but we reject the null. Well, okay. All right, and another way we could word this would be the mean annual coffee consumption is 23.2 gallons, but we decide it is not equal to 23.2 gallons. All right, let's think about a type 2 error. So a type 2 error is just a flip-flop of the type 1 error. And so a type 2 error is H naught is false, which also means that the alternative is true, but we fail to reject the null. Okay, and so we're going to decide that the alternative is true. So the mean annual coffee consumption is not equal to 23.2 gallons, but we fail to reject the null. Okay, and so see how that's kind of a flip-flopped version of the type 1 error. All right, what you're going to see when we get to JASP is that we are only going to be dealing with one sample t-tests. All right, and that is done on a continuous random variable. But I want you to know that we can do these one sample tests on proportions or percents. All right, and so we're going to practice a few of these proportions. All right, and so here the Western Blot assay is a blood test for the presence of HIV. It's been found that this test sometimes gives false positives for HIV. A medical researcher claims that the rate of false positives is 2%. A recent study of 300 randomly selected U.S. blood donors who do not have HIV found that 3 received a false positive test result. At alpha equals 0.05, can you reject the researcher's claim? All right, so again, here is our claim statement. All right. And now we are dealing with the proportion, so we're not going to write mu. We can just write p for proportion, although really it's the Greek letter rho. It just so happens that a rho is basically a p, an italicized p. All right, and so what is the claim here? A medical researcher claims that the rate of false positives is 2%. All right, so when I read that, I type p equals we can either say 2% or 0.02. All right, doesn't matter. All right, that is the one we read in the sentence, so that is the claim. It contains an equal symbol, so that is our null. Now we just need to write our alternative, and that would be p, and I'm going to copy our not equal to 0.02 or 2%. All right. All right, so now we want to interpret our type 1 error. So again, this means that the null is true, but we reject it. All right, and so what does that mean? It means that the rate of false positives is 2%, but we reject the null. All right. This is equivalent to, I think one of the easiest ways to think about type 1, type 2 errors is with our legal system. And we've got the absolute truth of the person on trial, right? That person is either guilty or innocent. And we use a jury of peers to try to get at that truth. And a jury can come back with a decision of guilty or not guilty, right? And so this would be a situation where the person is innocent, but the jury comes back as guilty. All right, which is a horrible thing to happen, because ultimately that's sending an innocent person to jail or prison. All right. The type 2 error would be that the person is guilty. All right, so then the alternative is true. The person is guilty, but the jury comes back with a not guilty verdict. All right. All right, so how do we say that for this problem? The rate of false positives is not 2%, but we fail to reject the null. All right, so hopefully it's starting to click. This may be the point at which you want to stop the video and do the remaining ones on your own and then come back to the video to check. All right, if not, let's just keep going. A researcher claims that the mean cost of raising a child age 2 and under by families in rural areas is $11,060. In a random sample of families in rural areas, the mean annual cost of raising a child age 2 and under is $10,920. The sample consists of 800 children. Assume the population standard deviation is 1561. All right, at alpha equals 0.01, can you reject the claim? All right, with all this wording, what is the wording that matters to us to write the null and alternative? It is only this first sentence. All right, that is the only one. And so we want to write our null and alternative based on that. And so we are going to just turn this sentence into a mathematical statement. And so we have the mean cost. So mu is $11,060, so equals 11,060. All right, and because it is, we are using an equal symbol, that means it is the null. Because it is what we read in the problem, that is the claim. And then from there, we can write our alternative, which is going to be the opposite, which is mu not equal to $11,060. All right, type 1, again, is that the null is true, but we reject it. All right, and so that means the mean cost of raising, oops, goodness gracious, raising a child in a rural area is $11,060, but we reject the null. All right, type 2 is pretty much flip-flopping those two things. All right, and so now the null is false, all right, but we failed to reject it. So the mean cost of raising a child in a rural area is not $11,060, but we fail to reject the null. All right. Moving on to number 4. A Greenville city planner claims that the mean speed of traffic southbound along I-85 during morning peak hours is less than 50 miles per hour. In a random sample of 45 motor vehicles traveling southbound on I-85 during morning peak hours, the mean speed is 51 miles per hour. Assume the population standard deviation is 5 miles per hour. At alpha equals 0.05, is there enough evidence to support the city planner's claim? All right, so in all this paragraph, what matters to us? To answer or to write our null and alternative, all we care about is this sentence right here. All right, and we are going to take that sentence and turn it into a mathematical statement. And what I'm reading is that the mean speed is less than 50 miles per hour. So the mean speed is less than 50 miles per hour. All right, notice now, this is a strict inequality, less than. There's no equal to it. All right, so that means that this is the alternative. because it is what we read, it is the claim. All right, to be able to write our null, it is the mathematical opposite of mu less than 50. So the mathematical opposite would be mu, and I'm going to need a symbol because we need greater than or equal to. I'm sure you've already found it. I don't know why there it is. All right, greater than or equal to 50. All right, so that would be our null and alternative. All right, we want to interpret a type 1 error. So again, this is where the null is true. So the mean speed is, so how are we going to say, so here's a great practice for you. What you don't want to say if you're trying to speak good English is the mean speed is greater than or equal to 50, right? We don't really, that's what our symbol says, but we have English that is a little bit better at saying that. So how do we say greater than or equal to? All right, the mean speed is at least 50 miles per hour, but we reject the null. All right, number 5. A restaurant association says the typical household in the U.S. spends a mean amount of $2,628 per year on food away from home. You are a consumer reporter for a national publication and want to test this claim. A random sample of 34 U.S. households has a mean amount spent on food away from home of $2,694 and a standard deviation of $322. At alpha equals 0.05, can you reject the association's claim? All right, so here we are. We want to test this claim. All right, so what do we do first? We write the mathematical sentence. All right, and so what I'm reading is that the mean amount, all right, spends a mean amount of 2,628. So we have mu equals 2628. All right, here we used equals, so that means that's the null hypothesis. It is what we read in the problem, so it is the claim. The alternative is the mathematical opposite, which is not equal to 2628. All right, and we want to interpret a type 1 error. All right, so again, null is true, but we reject it. All right, and so the mean amount spent on eating out is $2,628, but we reject the null. All right, number 6, a polling agency reports that over 60% of U.S. adults think that the federal government's bank bailouts were bad for the U.S. In a random sample of 298 U.S. adults, 167 said that the federal government's bank bailouts were bad for the U.S. At alpha equals 0.01, can you support the agency's claim? All right, what's the claim? The claim is our first sentence here. All right, and this is one that's going back to proportion. You know that because it's a percent. A polling agency reports that over 60% of U.S. adults think this about the federal government. So the proportion is greater than 60, or I should say 0.60 or 60%. All right, that is a strict inequality right there. Greater than is a strict inequality, so that is going to be the alternative. It's what we read in the problem, so that's the claim. All right, we need the mathematical opposite for the null hypothesis. So that would be the proportion is less than or equal to. So we need to find our less than or equal to symbol. Why do I not? Oh, there it is. All right, less than or equal to 0.60 or 60%. All right, interpret a type 1 error. So again, null is true, but we reject it. So what do we want to say here? So how do we say less than or equal to? No more than 60% of U.S. adults think Bailouts are bad, but we reject the null. All right, last problem. A fitness magazine claims that the mean cost of a yoga session is no more than $14. You work for a consumer advocacy group and are asked to test this claim. You find that a random sample of 32 yoga sessions has a mean cost of $15.59 and a standard deviation of $2.60. At alpha equals 0.01, can you reject the magazine's claim? All right, so what is our mathematical statement for our claim sentence? All right, well, the mean cost is no more than 14. So the mean cost is no more than, all right, no more than is less than or equal to 14. All right, because this includes equality, less than or equal to, that is the null hypothesis. It's what we read in the problem, so it is the claim. And then our alternative is the mathematical opposite of this. So opposite of less than or equal to is greater than 14. All right, interpreted type 1 error would be that the mean cost of yoga, well, I should say a yoga session, is no more than $14, but we reject the null. All right, well, hopefully with those 7 problems, you're feeling much more confident about writing the null and alternative, and you're ready to learn how to handle the data in JASP.